Morning, Year 10. In this lesson, we're going to be talking about cubics. Now, what is a cubic? Now, you'll notice, so we talked about parabolas. We spent 2 lessons on parabolas. Now we're talking about cubics. So, there's a bit of a progression. So you'll learn about linear lines, which is, obviously a straight line, where the highest power is 1, x to the power of 1. Then parabola is x to the power of 2. A cubic is where the highest power is 3. Okay, so a normal cubic equation is like this. Now this is in its general form, so we would have ax cubed plus bx squared plus cx plus d. Now that's very full on. There's a lot of stuff going on there. So the way we do it, we only really care about these 2 aspects. We care about this part and we care about this part. The other parts in between, they make things a bit confusing and they muddle it up. So we just will focus on the highlighted sections. Okay, now there's 2 basic looking cubics. There's this one here, which looks like that. And cuts at the origin here. Okay, and that's so that's 1 cubic. And that's actually a positive cubic, okay? So that's the positive cubic. And then we can have another one which would look this way. And that is a negative cubic, okay? So that's the general look, and I'll just write negative. It's the general look of them. Now, the reason why the other number that we only care about is, and when I say care, like the only one we focus on is this one. Now we're talking about it D, but it's a number that has no x's. That determines where this cubic is shifted to vertically. So if it was positive, let's say we added 2, it would look the same, but now it's up 2. If it was 5, it would look the same, but it's up higher. If it was negative 2, it would be down here. And the same goes for this one. You might have it up there or down there. It can be shifted up or down depending on what that is. Just like with the parabola though, we also have the A. The A determines how close everything is together and how far away. And so if this was so let's say this is y is equal to x cubed, so a really basic one. If it was 2x cubed, it would look like this, a bit more steep. And if it was a half x cubed, it would be less steep. Okay, so it would look a bit shallower. And that's basically it. So we're taking a lot of the things that we know about parabolas and putting it into a cubic. But the reason why we don't use cubics as much is because you'll learn more about it in year 11, 12, but they're not as interesting with a cubic. We care more about parabolas. Doesn't mean it doesn't come up though. The other reason why cubics don't come up as much is because they are harder. They are significantly harder to determine some simple things that we can with a parabola that we can't do as easily with a cubic. Okay, so for our single only example we're doing today, we're going to be looking at just graphing different cubics. Okay, we're going to graph them all on the same plane. And so, like before, we're just going to do a table of values, put it on the axes, and then we can go home. Oh, I guess we already are home, so we can stay where we are. Yay! So let's look at this example. So the example says to graph y equals x cubed plus 1, y equals minus x cubed plus 3, and y equals minus 3x cubed minus 5 on the same plane, showing the y-intercepts. So I'm going to graph this as big as I can. So we'll go all the way down to there. And the middle's roughly here. There we go. And each line will be 1. But like before, other lessons, I'm going to go up and only count every second one, because otherwise we'll just be here for literally twice as long. So we'll just go up to there, 2, 4, 6, 8, and negatives. Oops. 4. Okay, and once again, the reason why we want to do it on the same axes, even though it looks messier, is because we want to actually be able to, have some time to ourselves. So we don't want to be drawing these axes all the time. Now, it says on the same plane, showing the y-intercepts. Remember, the y-intercepts are just where do they cross this line. I should probably label that. That's my x, and that is my y. Okay. So we'll do a table of values. I'm going to do it in the top left-hand corner. So I'm going to have x and y. And we've got -3 all the way to 3. Remember, it's a curved line, so we want to have as many options as possible. Now, without too far, like we don't want to go crazy. We could go to 5, but man, there's just a lot more to do. So we'll just go to this far. And once again, I'm going to label these. So this is 1, 2, and 3. And what I'll do is I'll rewrite how I would write in the calculator. So I'll write it as bracket cubed plus 1. So I'm going to go through and pop it in there. So I'm going to have -3 cubed plus 1, and -3 is in the brackets. I get -26. That's not going to fit on my graph. -2 is -7. That will. -1 is 0. 0 is 1. And where things are different to this compared to a parabola is we don't really get a point of symmetry. Okay, that doesn't really happen. It will look sort of symmetrical, but it's not, because it goes the opposite direction. So yeah, it's not symmetrical in this case. So I've gone through -3, done that for every single one, and then I've got those points. So I'm going to plot the points that will fit on my graph. So -3 won't. -2 to -7, that will. So I'll have a dot there. -1 and 0, so that's there. 0 and 1's there. 1 and 2 is there. 2 and 9 is there. Okay, now you'll see that this is the point where things start to change. So I'm going to have my line going curved up to there, and that's where it's going to stop. And then I'm going to start the line again, but going the other direction, and that's where it's going to stop. And that's my first cubic. All right, I'm going to do it again, but for 2 this time. Okay, so for 2, I'm going to write it in the calculator like this. Negative bracket cubed plus 3. I'll put that into the calculator. So I'm going to have negative bracket, -3 bracket cubed plus 3 will give me 30. That's not going to fit. 11, 4, 0 is 3, 1 is 2, 2 is -5, and 3 is -24. Okay, so we'll do that again. So I'll do a different color this time. -3 will not fit on the graph. -2 and 11. It won't fit on the graph, but I'm going to plot it anyway. So that's going to be 8, 9, 10, 11. So that's where the dot is up in the question. Then -1, 4. Then 0, 3. Then 1, 2. 2, -5. And then -24 is not going to fit. But you'll see, once again, we've got that point where it will change direction. So I'm going to go down to that point, and then come back around. And I'll keep it going past that dot. We want to try and fit as much of the graph in the space as possible. All right, now we've only got one more to do, and then we can enjoy the rest of our Friday by doing maths questions. How else could we enjoy our Friday? So, negative 3x cubed minus 5. All right, I'll pop that down. So we've got negative 3 bracket cubed minus 5, and I'm going to go through and put that into the calculator. So negative 3 with the brackets, negative 3 again cubed minus 5 gives me 76. That's not going to fit on the graph. Negative 2 is 19. That's not going to fit on the graph. Negative 1 is negative 2. That'll fit. 0 is negative 5. 1 is negative 8. Well, at least we'll have some things fitting on the graph. Negative 29 won't. And then 3, probably not as well. It's negative 86. Yeah, that's not going to fit. All right, now we have all of those numbers. We'll plot them on the graph, the ones that we can anyway. So 76 won't, 19 won't. Negative 1, negative 2 will. 0, negative 5 will. 1, negative 8 will. And that's about it. Now that's not very helpful. It looks like a straight line. We know it's not, but we need some more information. So where things start to go weird is in this zone here and in this zone here. So I'm going to put in a different number just to kind of give me a bit more of an idea of what's going on. So now I'm going to do it on the right hand side. So I'm going to add in 2 more values to our table of values. I'm going to see what happens at negative 1.5 and positive 1.5. Let's see what happens there. So I've still got it in my calculator, negative 1.5. Okay, I get 5.125. And if it was positive 1.5 is negative 15.125. I can plot them, well, I can't plot the negative 15, it's a bit too big, but we've got the general idea, right? If we have negative 1.5, so that's here, I get 5.125, so it's around here. Okay, I'm going to put that point there. Now I'm starting to see the drawing a little bit better. And when we go to positive 1.5, we go to 15 something. So it's probably going to be still pretty high up there. But we've got a bit more of our drawing. It looks like this. Okay. And the reason why it looks so tall is because of that 3. The 3 means that we're going very, very narrow. The other ones are a bit easier to draw. This one's a bit harder. So as long as we get the general idea of the picture, it's not too bad. But yeah, I guess the only thing to say about my drawing here is it looks a bit more like a straight line than a cubic. So one thing I might change, I'll do it again, just to make sure that we can get the drawing to be as close as possible. I'm gonna do a bit of a line here, similar to my second one. And if I do it like that, it looks a bit more like a cubic. But aside from that, it's basically the same. Yeah, it just looks a bit more like a cubic that way. That's why it's important to know what the difference between a positive and a negative cubic is. Which parts are going up and which parts are going down in those curvy ways. So here we only had one positive. That's the positive there. Then we had a negative, and then this one's a negative as well. The point of these drawings is we just want the general idea, but one thing it did ask for is the y-intercepts. So I'm just going to label them in the different colours that we used. So for, the first one was black. So this point here was 0, 1. In blue, this point was 0, 3. And then the pink one was 0, -5. And we've done it. We've shown the y-intercepts. And that's all we're really going to be doing with cubics. Just graphing them and looking at how they might look positive or negative. Have they shifted up or down? Do they look narrower? Do they look wider? And that's basically it. Anyway, I hope you enjoy the rest of your day, and I'll talk to you next week. Thanks.